Hello, we're at University of New South Wales and I'm Norman Wildberger. This is question 15 from chapter 1 of the algebra notes of Math 1131. We're looking at vectors. This question asks, suppose that v equals the vector 2, 3 and w is the vector minus 1, 1. We're asked to draw coordinate axes and mark the points whose coordinate vectors are v, minus v, w, v plus w, 2v, and v minus w. Okay, so we need a diagram, and it should be a half decent, reasonably big sized one because we want to draw a fair number of points. We want to do so reasonably accurately. All right, so let's start by trying to draw straight lines. Okay, that'll be the x. That'll be the y. We're looking at the vectors 2, 3, minus 1, 1. Those numbers are not too big, so we don't need too fine a scale. Perhaps we'll put 1 about there. Okay, so that's 2, 3, 4, 5, minus 1, minus 2, minus 3, and so on along the x-axis. And then along the y-axis, well, we'll choose a similar scale. In fact, it doesn't actually have to be exactly the same size as this scale, but it's usual to do so. 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on. All right, so probably a good place to start is to, first of all, draw the vectors themselves. Well, they're included in the question anyway, so let's draw v and w. So where is v? V is the vector that starts at the origin and goes to the point 2, 3. 2 this way, 3 that way. So we're going up to about there. All right, so we're going to draw, there is the vector v. Okay, might as well draw minus v. Okay, so minus v is the vector that goes in the opposite direction. So it's going to go minus 2 and minus 3. It's going to go down to there. All right. So this is the vector minus v. And the points whose coordinate vectors are these are the points right here. So that's actually a point. And that's actually a point too. And sometimes it's useful to distinguish the points themselves from the vectors. So this point could possibly be labeled in a different way. For example, we could label it with square brackets 2, 3. That's something that I like to do. And this point here would be the point minus 2, minus 3. Of course, to any point, there's associated the vector that starts from the origin to that point. Okay, so that point 2, 3, we say that its coordinate vector is this one here that starts from the origin, which of course is the point 0, which I often don't label, but it's there. 0, 0 in both directions. Okay, so that vector there is the coordinate vector for that point. All right, so we've got v and minus v. How about w? Where is that? W is minus 1, 1, minus 1, 1. So it will be there. There's the vector w. And the point whose coordinate vector is that vector w is that point right there, which would be the point minus 1, 1. How about v plus w? Well, we should compute what that is. So v plus w is 2, 3 plus minus 1, 1. And that is 1, 4. Where is that? That is 1, 4 right about here. So there is the vector v plus w. There it is there. And the corresponding point is this one here. And of course, its in terms of its coordinates, the point would be 1, 4. And maybe I'll remark that there's in fact a parallelogram formed here, right? When you're adding vectors, you're really forming a parallelogram. So there's V and there's W. These 4 points actually form a parallelogram. And in particular, this side, that vector, is exactly the same as that vector. Just been translated up there. Okay, what about 2 times V? 2 times V is 2 times 2, 3, which is the point of the vector 4, 6. And where is that on our picture? Well, 4, 6, 3, 4, 5, 6, be up there. So probably have to go all the way up to about there. In fact, that would be the point right there, whose coordinate vector is 2 times V. And 2 times V is this vector that goes all the way up there. Starting from here, all the way through this point, all the way up to that point there. So that's the vector 2 times V. And finally, we have V minus W. V minus W, which we compute using the coordinates 2, 3, minus 1, 1, which is 2 minus 1 is 3, and 3 minus 1 is 2. And where is that? That's 3, 2. 3 this way, 2 this way. So we're up about there. There is the vector V minus W. And there's an important remark to make about that. Probably first I should draw the point that we're actually asked for. So there's the point whose coordinates are 3 and 2. That would be the point 3, 2. Okay. So that point, which is just that single point there, has coordinate vector V minus W. And the physical significance of V minus W, the difference of 2 vectors, is very important in vector geometry. It's what you get when you look at the vectors V and W, and you go from the head of W to the head of V. So let me draw it in red. Okay. So this vector here, that goes from the head of W to the head of V. This is the vector V minus W. So final minus initial. And that's the same vector as this one here. Just that here we've moved the vector down so that it's starting at the origin, which is sort of the canonical place for it. But this is just as valid a representation of that vector as this one is. So the difference between 2 vectors is a very important notion that comes up all over the place in physics and engineering. So when we're taking V minus W, it's a vector that goes from the head of W to the head of V. And you should think about it in terms of algebra. If you take W and you add V minus W, so you take this vector and then you add that vector, well, the cumulative effect is to get the vector V. That sort of explains that. All right, so there we have our diagram with the required points on it.